Good morning, my dear students. Hope you are well. Today I'm going to continue the explanation of Chapter 11, Carboxylic Acids and Derivatives. The topic is the second acid derivative, which is acid anhydride. The objectives that you will be able to understand at the end of the session are the following. The first one is to define acid anhydride and represent its general formula. The second is to name the acid anhydride using IUPAC system. The third one is about chemical reactions, how to prepare an acid anhydride from two identical carboxylic acids, and the second, how a mixed anhydride is prepared. Here is by using two methods. The first method is by using two different carboxylic acids. The second method is by using acyl chloride and sodium carboxylate in a non-aqueous medium. And the third objective is how to explain hydrolysis reaction by identifying the hydrolysis reaction of acid anhydride, and the last one is to give some characteristics of the reaction of hydrolysis of acid anhydride. Now let's start with a revision of carboxylic acid derivatives. Last time you have taken the acyl chloride, how can be prepared from carboxylic acid in the presence of SOCl2, and this reaction is called substitution reaction. Today we are going to explain how to prepare the second derivative, which is acid anhydride, starting also from carboxylic acid and with another carboxylic acid. And the third derivative, you will take it next time, which is ester. As you remember that ester is prepared from alcohol and carboxylic acid, and the reaction is called esterification. And the last derivative, which is amide, but you are not responsible for this topic this year. Let us begin with the first objective, which is define acid anhydride and represent its general formula. What is an acid anhydride? It is an acid derivative where the hydroxyl group is replaced by the alkanoate group RCOO-. So as you see here, the OH is replaced, or it becomes OC double bond OR is replaced by group of atoms. How acid anhydride are used? Acid anhydrides are commonly used in organic synthesis such as aspirin and paracetamol. They are irritating. Why they are irritating? Because they are very active. The order of the activity of acid anhydride is between those of acyl chlorides and esters. They react more slowly than acyl chloride. Now the general formula of acid anhydride is written as CnH2n-2O3. It means the acid anhydride consists of 3 oxygen atoms, and this general formula can be also represented as RC double bond O, OC double bond O, R prime. Its structural formula, as you see it here, you have 2 R. two alkyl radicals. What about them? If the alkyl groups R and R prime are identical, as you see here, you have CH3 and CH3. The two are identical, and in between you have the acid group, which is the functional group of the acid anhydride. It is C double bond O, O, C double bond O, C double bond O. Now, if the two are different, the anhydride is called mixed. And the example here, you have one R which is CH3, the other R is equal to H, to hydrogen atom. Now what about if R is equal to R prime equal to H? You have this molecule where the hydrogen is bonded to carbon and the other hydrogen also is bonded to the other carbon. Now the second objective is how to name the acid anhydride. We have here two rules. If the two alkyl groups are identical, you name the carboxylic acid and then replace the word acid by anhydride. Let's take an example. Look at the table here well. Let's take the first formula where you have only two carbon atoms, one on each side, or they are present in the functional group of the acid anhydride, and the R here, both are equal to hydrogen. What does it mean? It means you have methanoic anhydride. The common name for it is formic anhydride. The second formula of the acid anhydride, you have here on the left side two carbon atoms, on the right side two carbon atoms. What does it mean? You have ethanoic and you name it ethanoic anhydride. Its common name is acetic anhydride. Now the third example is the formula where you have here three carbon atoms on the right side, you have three carbon atoms on the left side. So in this case you have two identical R, and the name is propanoic anhydride. The common name is propionic anhydride. Now the second rule, if the two R are different, we call them mixed anhydride. How do we name the acid anhydride? You follow here alphabetical order. So the name, to name the carboxylic acid using alphabetical order, and then replace the word acid by anhydride. Example of this, let's see. The first example, you have on the left side you have one carbon, on the right side you have two carbon atoms. It means you have ethanoic and you have methanoic, but the E is before the M, so you name it ethanoic methanoic anhydride. Now the last example, also look at the condensed structural formula. What do you have on the left side? You have the R consists of three carbon atoms with the carbon of the functional group, so it means you have four carbon atoms, you have butanoic acid. On the right side you have three carbon atoms, so it is propanoic acid. Now how to name this acid anhydride? The B is before the P, so you name it butanoic propanoic anhydride. Now the third objective is about chemical reactions. Let's start with the first chemical reaction, which is preparation of an acid anhydride from two identical carboxylic acids. An acid anhydride is prepared by intermolecular dehydration of two molecules of carboxylic acid. Let's remember together. What do we mean by intermolecular? It is a reaction that takes place between two molecules. Okay, and what is dehydration? It is the removal of water. It is the opposite of hydration. In hydration, you have the addition of water. So, what is going on here? You have the hydroxyl group from the first acid and the H atom of another carboxylic acid, which is the second acid, are eliminated as water, and a molecule of acid anhydride is formed according to the following equation. What do we have here? We use a catalyst, which is P2O5. It is a powerful dehydrating agent, and it is called phosphorus pentoxide. Now, to explain this one more, let's take an example. You have the ethanoic acid. The OH is removed from the ethanoic acid from its carboxyl group, and the H is also removed from the carboxyl group, or exactly from the hydroxyl group of the carboxyl group, and the elimination here will produce water in the product with the formation of the acid anhydride. How do you name this acid anhydride? It is ethanoic anhydride. Now, how do you prepare a mixed anhydride? We have here two methods. The first method is by using two different carboxylic acid to prepare a mixed anhydride. A reaction is carried out under the same conditions as the preceding case, but the reaction here is reversible. So the equation of the reaction is the removal of OH from the first carboxylic acid, the H from the second carboxylic acid. They will eliminate water, or water is formed in the product, and the formation of the acid anhydride. The catalyst is the same as the preceding one. It is P2O5 and in the presence of heat. But here you have to pay attention that you don't get only mixed anhydride, you get also two products of the acid anhydride where they are here is similar. So let's take an example to understand this more. We will take ethanoic acid and propanoic acid, two different carboxylic acids. The same thing, the OH is removed from the ethanoic acid, the H is removed from the propanoic acid, especially here from the OH, from the hydroxyl group, in order for water to be formed, or by elimination of water and formation of a mixed anhydride, which is ethanoic propanoic anhydride. This is not the only reaction that will take place. We have also two reactions that will produce two anhydrides. Let's see them. The reaction we say here is the two ethanoic acid, the two molecules of ethanoic acid. What happened to them? Also the same thing. The OH is removed from the first carbon atom, from the hydroxyl group, and the H from the second hydroxyl group of the ethanoic acid. to eliminate water and formation of ethanoic anhydride having identical R. Also, the propanoic acid, 2 molecules of propanoic acid undergo, in this case, dehydration, intermolecular dehydration, and the product will be water and the propanoic anhydride having the same R. Now the question here, how can we produce only one mixed anhydride without these two products? In order to prepare only a mixed anhydride, we have to use acyl chloride and sodium carboxylate in non-aqueous medium. So, to obtain only the mixed anhydride, a reaction should be carried out between an acyl chloride, which is the most reactive derivative of carboxylic acid, and sodium alkanate or carboxylate, which is R prime COO minus, comma, Na plus in a non-aqueous medium. Instead of plus, we write comma because the medium is non-aqueous, or we say in absence of water. So, in general, you have the acyl chloride plus the sodium carboxylate. We'll get the acid anhydride, which is mixed anhydride, plus sodium chloride. This sodium chloride you can write it with comma between the positive ion and the negative ion in absence of water. So, let's take an example here. So you see first the comma and the comma here instead of plus. Example, let's take ethanoyl chloride plus sodium propanoate. What do we get? We get ethanoic propanoic anhydride, which is the mixed anhydride plus sodium chloride. Now the last reaction, chemical reaction, is hydrolysis reaction. So what is hydrolysis reaction here with respect to the second derivative? An acid anhydride undergoes hydrolysis reaction readily. The reaction is slower and less violent than that of an acyl chloride. The equation of the reaction is as the following here. You have the blue part is the remaining of the first acid. The green part is the remaining of the second acid. Now, in the presence of water or hydrolysis reaction, the H here is going to return to the first carboxylic acid, and the OH is going to return to the second carboxylic acid. So you will get here 2 carboxylic acids. Example of hydrolysis of acid anhydride, you have ethanoic anhydride plus water, you get 2 molecules of ethanoic acid. Here I want you to pay attention that if we ask you to determine the number of moles of the ethanoic acid formed, you have to use the stoichiometric ratio, which is number of moles of ethanoic anhydride reacted over 1 equal the number of moles of the ethanoic acid formed over 2. Don't forget this stoichiometry. Now, what are some characteristics of the reaction of hydrolysis of acid anhydride? These characteristics are the same as for acyl chloride. Let's see them. The hydrolysis of acid anhydride is complete. You have complete reaction, one direction. You have fast reaction, it is fast, and exothermic reaction. Now it regenerates the corresponding acid if water is present. Therefore, the anhydride must be constantly protected from humidity. Now, let's make a summary of hydrolysis of acid derivatives. The first derivative, which is the acyl chloride, it is the most reactive one. Plus water, what does it give? It gives carboxylic acid. Now, the acid anhydride undergoes hydrolysis also to give how many carboxylic acids? To give 2 carboxylic acids. And the ester, you will take it next time, with plus water, it undergoes hydrolysis to give carboxylic acid. And what is the second product? It is alcohol. And the last one, which is the amide, it is the least reactive one. In presence of a strong acid, it will give carboxylic acid. Finally, before we finish our presentation, Einstein has a question for you all. Why should a dry Erlenmeyer flask be used when dealing with acid anhydride? These two students answered the following. The first answer is, she said, to prevent hydrolysis. The second student, he said, to prevent the regeneration of carboxylic acid. In your opinion, which answer is correct? Actually, both answers are correct, since they have the same meaning. By preventing hydrolysis, you are preventing regeneration of carboxylic acid. Hope you are interested in this session. Thank you.